Hello guys, welcome to my new channel Study Up. I am Shankar sir. So today I will discuss about the second part of periodic table. Those who have not seen my the first part, so go to the description box where my link is given. Go to this link and learn it. Let's begin for today's discussions. Part 2. So I have already come here to discuss about the next part, that is the modern periodic table of the elements, that is the long form of the table. In the long form, what we see, there are 7 periods and 18 groups are there, and you have to find out the elements present in each periods. How to find out, and you should have to know the number of elements in periods. See, in the first period, that is hydrogen and helium, only 2 elements are there. In the second period, 8 elements are there. Third period also 8. Fourth period also 18. Fifth period 18 elements are there. Sixth period 32 elements, and seventh period are there. I will discuss later. Extra is not completed period, that is 32 plus elements are there. Here we will see a new thing. You will observe the rhythms, a sequence 2, 8, 8, 18, 18, 32, 32 plus. These 2, 8, 8, 18, 18, these numbers are called the magic numbers. In the periodic tables, these numbers are called the magic numbers. Why do we call this number magic numbers? Because this is called magic numbers because if you add magic number with any elements in periodic tables, then we will get the number which will be just below the element you have taken. Suppose group 1 hydrogen, group 2 lithium, group 3 sodium, just below the sodium potassium, and just below potassium it is rubidium, just below rubidium cesium. Next come, if you add with the number hydrogen, the magic number 2, you will get lithium, which the number will be 2 plus 1, 3. Just lithium to sodium, you have to add the magic number 8. 8 plus 3, 11. Same way, sodium to potassium, sodium 11, 11 plus 8, 19. Just below number you will always get. And potassium to rubidium, 19 plus 18, 37. Rubidium to cesium, 37 plus 18, 55. And again, cesium to francium, 55 plus 32, 87. In this way, you will get any number. Not only this group, only in this period, any, you can catch up from any groups. But you have to remember which groups you are taking. Suppose it is taking from second group, you have to add 2, 8. Suppose you are taking the third group, you have to add 8. Fourth group, you have to add 18. Okay, in this way. 4th to 5th, 18. 5th to 16, 18. This sequence you have to remember. Suppose you have to take out there osmium. Osmium is the number 76. If we add osmium in the group period 6 period osmium 76, you have to add 32. Then you will take the number just below osmium, helium. What is the number of heliums? 108. That 76 plus 32, 108. Anywhere. Iron to ruthenium. Iron कितना है? 26. Ruthenium कितना? 44. That 26. Iron 26. Fourth group. You have to add what? Fourth to fifth. You have to add 18. So you have to add this number and you will give 44. In this way, you can find out any number. Add the magic number with any of the elements in the periodic tables. You will just obtain the just below the number what you will want. Okay, or I am coming next. Now I will discuss about the nomenclature. What is the nomenclature out here? In the periodic table, what is see how to name the newly discovered element. So many elements is being discovered continuously, so we have to give the proper name, because sometimes many scientists claim, as for example 104 the elements. Some American scientist told he has invented it. British scientists told he has invented it. Okay, so Soviet scientist he has invented. So in this way there is a problem. What's the problem? Who has actually invented? So to solve this problem, a particular nomenclature name should be given. To solve this, IUPAC, CNIC, this system, UPAC system, a process to give a temporary name. And this system, total system, it is controlled by the UPAC system. And in these systems, you can give official names and the UPAC name. So let us start how to give the newly invented. That is the whose atomic number more than 100. 100 का जो ज़्यादा है उस नंबर के लिए what is the process to give the name. Suppose in case of you have to follow this table, this is 0. In case you have to add nil, abbreviation N, 1 only un, U, 2 by, 3 will try, 4 quad, 5 pen, 6 hex, 7 sept, 8 oct, 9 N. In this way, you have to give the name. Then there will be no confusions. Suppose an element which atomic number is 105. So what will be the name of that element? In that case, 1 means un, 0 means nil, 5 means paint. Nil paint, nil pentium. Abruptly you can take another number 113. So what will be the name in this next system or UPAC system? What is the 1 means? 1 means 3 means try. Try. Triumph. In case of suppose 120, what will be the name? 1. What is this? 2 by 0 means nil. So what is the name of this element? Suppose after invention, what is the name? 120, by nil, by nilium, UBN, short form, UBN, by nilium. Okay, clear? So this is the table you have to follow, how to nomenclature, how to give a proper name of the element to be discovered. Okay. Next. Now दोस्तों, अभी you should have to remember, not required to remember, which element is where, that is in which period and which group present. Suppose you are asked platinum, in which period and which group. इतना सारे elements, कैसे remember करोगे? Is not possible. So from the electronic configurations, we can easily remember the position of the element in a periodic table. But it is not easy to remember for a particular student, which is what, where is the particular element present. Though there is a song, I will give you the how to remember a song style. So it is not possible to learn the song. That is the old fashion. But the new fashion is what we have to learn. From the electronic configuration, you can easily find out the position of an element in the periodic table, which group, which period. Okay, that is the electronic configuration. From the electronic configuration, what we will learn? The electronic configurations, it will help in placing the new elements in periodic tables. And from electronic configuration, the highest value of principal quantum number determines the period of the elements. Yes, highest value of quantum number, that is the n. The highest value of quantum number n, it determines the period of the elements. A highest value of n takes the period number. If the highest value of n 1, that is, it is in first period. If the highest value of n is 2, it is second period. If the highest value of n is 3, it is third period. If the highest value of n is 4, it is the fourth period. If the highest value of n is 7, it is 7 and it is in seventh period. Okay. So from the electronic configuration, you can easily determine in which period it exists. And then I will come to which group. So first I am given an example. Suppose give an example of nitrogen. Nitrogen electronic configuration, all you know in the yesterday chapter. You have in the atomic structure, you have learned the electronic configuration 1s2, 2s2, 2p3. We have the highest value of n is what? 2. The n value is 2. So what is the value of n gives? It gives a period number. So nitrogen in period number, second period. See out here, second period is nitrogen. Okay. Second period, okay. Nitrogen, clear? Suppose the actinium. Actinium, you have to find out the electronic configurations are n 6d1 7h2. The highest value of n is what? 7. So it is 7th period. It is 7th period. Actinium, clear? This is 7th period actinium. Clear? Then comes to group. You will determine the period number and which period and which group you have to find out the group. Period number is already clear, all of you, but sure, clear. Next come how to find out in which group it is existing. It exists. The elements in a group that have same number of what? Valence electron. In a group, what you have to find out in which group? The number of valence electron. In a group have same number of valence electrons. Suppose for S block, I will discuss just after this. The S block element, P block element, D block elements, A block elements, total periodic can be classified. I will discuss later. So if the element is in S block element, then in which group it will exist? In case of S block elements, the number of valence electron is the group number. Number of valence electron is the group number. Clear? Suppose, and in case of P block elements, 10 plus number of valence electron. You should remember this. In case of D block elements, it will be the number of electron in n minus 1d subcell plus number of valence electron. In this way, you can easily find out in which group the element exists. Suppose what I find out, the nitrogen N, it is in the second group and it is in the 15th second period and 15th group. How? So what I see, nitrogen 1s2, 2s2, 2p3. Okay. So what is the number of valence electron? 5. What is the formula? 10 plus number of valence electron. 10 plus valence electron 5. that is 10 plus 5 equals to 15. It is the group number. Nitrogen is group number 15. Period 2. Clear? Nitrogen is clear. Second period has the highest value of N2 and period is second group is 15. In this way you can find out anything. Any. Suppose in the group elements you can find out anything. Hafnium you can easily find out. It is the in this way sixth period and this is the fourth group. You can find out any. Okay, by applying this formula. Okay, I am coming next. I will discuss in the next class. Next class, Abhi, that was the total classification of the fluid in different blocks. Okay, to next. Now start. Now, on the basis of the electronic configuration, there are total 4 blocks in periodic tables on the basis of electronic configuration. Okay, total periodic table. There are 4 blocks: S blocks, P block, D block, A block. Again, S block, P block, D block, A block. Now I will discuss part by part. S block elements. S block elements का क्या feature है? The last electrons in S block elements. What are the S block elements? Group 1 and group 2. These are the S block elements. Total. Group 1 and group 2 are the S block elements. And to last electron enters into S subcell. All are their electronic configuration. If you notice in this periodic table, in your book or this chart, you will see each element have the last electron goes to S electron. Okay, S orbital, S subcell. As S subcell have only one orbital, you know, in yesterday class I have discussed, and can have maximum 2 electron. One orbital में कितने electron है? 2. So only group 1 and group 2 belongs to this block. Here, S subcell have only one orbital and can have maximum 2 electrons. So only group 1 and group 2 belong to this block. Here, the group 1, it is the alkali metals. All these are alkali metals. Lithium, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. All are alkali metals. In group 2, beryllium, magnesium, calcium, strontium, barium, and radium. All these are the alkali earth metals. Alkali earth metals. And what is the characteristic of these 2 groups, 1 and 2? They are soft metals and have low boiling point and low melting point. And general electronic configuration of this group, of these S block elements, what will be the general electronic configuration? If you configuration, suppose sodium, potassium, whatever you can try at home. The general configuration will be NS1 to 2, NS1 to 2, N equals to 1 to 3. This is the general electronic configuration. As for example, suppose lithium. I will not give, so time will be elapsed. I will give only one example. You will practice at your home. Then it will be clear to you. Lithium का configuration क्या होगा? 1s2, where then 2s1. तो देखो NS1 to 2. Clear? Lithium NS1. N का मतलब 2, S1. तो NS1 maximum 1 to 2. Clear? Cesium और कैल्शियम. कैल्शियम क्या होगा लास्ट में? 3p6 4s2, 3s2 3p6 3s4s2 कैल्शियम, 1s2 2s2 2p6 3s2 3p6 4s2. लास्ट में कैल्शियम का लास्ट में क्या होगा? 12 3p6 4s1 नोट ऑफ 3p6 4s2. क्लियर? NS1 to 2 maximum. Clear? Next I am coming P block. Okay. P block elements. This is the P block elements. All these are P block elements. Okay. P block elements, इसका last electron goes to p orbital. Since p orbital में कितना सब शेल है? P subshell have maximum 6 electrons. So 6 groups, that is group 13, 14, 15, 16, 17, 18. 13 से 18 तक. This belongs to this block. The P block consists of group 13 से group 18. Clear? Group 15, 16, 18 elements. Group 15, group 16, group 17, group 18. ये जो elements है ना, स्पेशल नाम है. क्या है? ग्रुप 15 को जो नाम है निकोजेंस, PNI, COGEN, निकोजेंस, ग्रुप 15 का नाम है. 16 निकोजेन का मतलब क्या है? चॉकिंग पाउडर, चॉकिंग प्रोड्यूसर. ओके. और ग्रुप 16 क्या है? चैल्कोजेंस. ग्रुप 16 के जो एलिमेंट्स है चैल्कोजेंस. ग्रुप 17 का की हेलोजेंस. ग्रुप 18 all you know noble gases. These are special names. The 16, 15, 16, 17, 18 are known as nicogens, chalcogens, halogens and noble gases. All the elements are generally nonmetals, but some are metal and some are metalloids also. And these have high electron gain enthalpy, negative, and ionization energy. High electron gain enthalpy and high ionization energy. And electron gain enthalpy, ionization energy, you are known. I have discussed in yesterday's classes, and also I will discuss if you thermodynamics also, atomic structure also I will have discussed, and chemical bonding also. Next, what is the general electronic configurations of P block elements? What will be the electronic configuration? It varies from NH2 NP1 to NH2 NP6. That means NH2 NP1 to 6. This is the P block element का general electronic configuration. NH2 NP1 to 6. Okay. Example. 13, 15. You will try. There will be configuration of 13, 15, 16, 17. You will get a series. 1:2, 2:2, 2p1, 1:2, 2:2, 2p2, 1:2, 2:2, 2p3. ऐसे. Okay. 4p4, 2p4, 2p5, 2p6, 2p6, and the NP 1 to 6. ऐसे. The 13 elements का जो बोरोन है, 14 ग्रुप का कार्बन, 15 में क्या है? नाइट्रोजन, 16 में ऑक्सीजन, 17 में बोलो क्लोरीन, 18 में नियॉन. If you electronic configure it, if you do the configuration of electrons, it will get, in case of 13 boron, 1:2, 2p1, and carbon 14, 1:2, 2p2, nitrogen 15, 2:2, 2p3, oxygen 16, 2:2, 2p4, ऐसे you will get, and this is the general configuration of NH2 NP1 to 6. Next, listen, group 1, 2, 13, 14, 15, 16, 17, 18. This represents the main group of periodic tables, and which are called representative elements. Very seriously remember. Group 1 and 2 and 13 to 18. This represents the main group of periodic table, and these elements of these groups are called representative elements. Next, D block. D block elements. The D block elements, these are known the D block elements. Okay? Clear? The group out here 1 to completed, 13 to 18 completed. Yes. So here last electron goes to inner d orbital. Why inner d orbital? This is the inner orbital. This is the inner orbital, inner d orbital group. That is the group 3. Out here 3, 1, 2 completed, 13 completed, remaining 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 3 to 12 are known as D block elements. They act as bridge elements. S blocks and S blocks and D blocks, less reactive S block. So they are named as transition elements. As they show transition, there is a change in behavior. These elements are known as transition elements. Why? What do you mean transition? Transition means change. The change होता है कि change in behavior. Behavior में change हो रहा है. All are not same behavior. What is that? They are all metals of high boiling points or high melting points. From there they form colored ions, partially D blocks, partially filled D block elements. Why colored ions? Because all the elements, the D block elements, fill partially. Okay, generally they are also generally paramagnetic. Paramagnetic means presence of unpaired electron in d orbitals. Paramagnetic in nature. Very important in case of d block elements. They are paramagnetic क्योंकि the presence of unpaired electron in d orbitals. Here, besides this, zinc, cadmium, magnesium, that is a group 12 में जो है zinc, cadmium, magnesium, do not exhibit actually the properties of transition elements. These 3 elements, zinc, cadmium and magnesium, is a group 12, and these do not generally exhibit the properties of transition elements. You will see the configuration of electric configuration. What you will see? 3d10, 4s2, 4d10s, 5s2, 5d10, 6s2. So not partially filled, not half filled, fully filled elements. So they do not show the transition, the behavior just like the transition elements. So what will be the general configuration of developed elements? N-1d, ns to n-1d, ns to 0 to 2. This is a configuration. Suppose iron. Argon 3d10, 3d6, 4s2. Iron एक है 3d6, 4s2. यार n equals to कितना है? n के वैल्यू n minus d, n equals to 4 और 4s2. तो n minus d क्या होगा? 4 minus 1, 3d. 3d clear? And ns 0 to 2. So 0, 4s2. This is the formula. Iron, if you find out the configuration of iron, it will be clear to you. n equals to 4. तो n minus 1 क्या कितना होगा? 3. मतलब आयरन का कॉन्फ़िगरेशन क्या है? आयरन देखो, then 3d6 and 4s2, n minus 1d माने 4 minus 1, 3, d 1 to 10, और ns 0 to 2. So it is clear from the configuration. Next, here bromine ions. I have already discussed, and I will discuss the A block elements and rest part of the periodic table in my next video. If any queries, so comment in my comment box. Okay, thank you.